NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will prove a beautiful identity about equal numbers. If a equals b equals c, then a cubed plus b cubed plus c cubed equals 3abc. We'll use a powerful factorization and a clean substitution. First, let's build an intuition for a equals b equals c. Think of three equal lengths labeled a, b, and c. All three are equal, so we can write a equals b equals c. Now, for the key algebra idea, there is a standard identity. Open parenthesis, a plus b plus c close parenthesis, times a squared plus b squared plus c squared minus ab minus ac minus bc equals a cubed plus b cubed plus c cubed minus 3abc. Next, we substitute the given condition. If it equals b equals c, then a squared plus b squared plus c squared equals 3a squared, and ab plus ac plus bc equals 3a squared. So the big bracket becomes 3a squared minus 3a squared, which is 0. That makes the whole product equal to 0. But that product equals the difference of cubes expression. So a cubed plus b cubed plus c cubed minus 3abc equals 0. Finally, rearrange. A cubed plus b cubed plus c cubed equals 3abc. The theorem is proven when a equals b equals c. Step 1. State the given conditions. We are given that x plus y plus z equals 0, and also that x cubed plus y cubed plus z cubed equals 0. Step 2. The original claim says for any natural number n, the sum x to the n plus y to the n plus z to the n equals 0. We will carefully test and refine this claim to make sure it is correct. Step 3. Use the classic identity for the sum of cubes of three variables. The sum of cubes minus 3x, y, z equals the sum x plus y plus z times a quadratic expression. Since the sum x plus y plus z is 0, the left side becomes x cubed plus y cubed plus z cubed equals 3xyz, but we are also given that x cubed plus y cubed plus z cubed equals 0. Therefore, 3xyz is 0, which means xyz equals 0. Step 4. Zero product property. If xyz equals 0, at least one of x, y, or z is 0. Step 5. Without loss of generality, assume x equals 0. Then from x plus y plus z equals 0. It follows that y plus c equals 0, so y equals negative z. Step 6. Evaluate the sum of nth powers under the relation y equals negative z. The sum becomes 0 to the n plus negative z to the n plus c to the n. This equals negative 1 to the n times z to the n plus z to the n. Now, here is the key point. If n is odd, then negative 1 to the n is negative 1, and the two terms cancel to 0. If n is even, then negative 1 to the n is plus 1, and the sum becomes 2 times z to the n. That equals 0 only if z equals 0, which forces y equals 0 as well. So the original blanket claim for all natural n needs a correction. A quick counterexample to the all natural n claim. Let x be 0, y be 1, and z be negative 1. Then x plus y plus c equals 0, and x cubed plus y cubed plus z cubed equals 0. But for n equals 2, the sum of squares is 2, not 0. This shows that the statement must be restricted to odd n, or the trivial case where all three numbers are 0. Therefore, the corrected statement is as follows. If x plus y plus c equals 0, and x cubed plus y cubed plus c cubed equals 0, then the product x, y, z equals 0, and consequently, x to the n plus y to the n plus c to the n equals 0 for all odd natural n. For even natural n, the sum equals 0 only in the trivial case when x, y, and z are all 0. Example. In this lesson, we will solve a cubic-looking equation by cleverly using the cube-sum identity with a correction term. Quick challenge. Before we start, can you guess which identity will help us convert this into a factorable form? Step 1. Rewrite the equation as a sum of 3 cubes minus the correction term. We will introduce w equals negative 1, so that 1 equals negative 1 cubed minus 3xy times negative 1, allowing the standard pattern to appear. Step 2. Apply the factorization with u equals x, v equals y, and w equals negative 1. The left side becomes the product of two factors, one linear and one quadratic. The linear factor is x plus y minus 1. Step 3. Use the zero product property. Since the expression equals 0, the linear factor must be 0. That gives x plus y minus 1 equals 0, or y equals 1 minus x. Let us visualize the solution set. It is the straight line y equals 1 minus x in the coordinate plane. We will prove a classic symmetric identity step by step, following a clear 5-step roadmap. Step 1. State the identity. The identity says 1/2 times parentheses a plus b plus c times the quantity, open bracket, the square of a minus b plus the square of b minus c plus the square of a minus c, close bracket, equals a cubed plus b cubed plus c cubed minus 3abc. We'll display it clearly before we expand anything. Step 2. Expand the squared terms. We use the expansions. A minus b all squared equals a squared minus 2ab plus b squared. B minus c all squared equals b squared minus 2bc plus c squared. A minus c all squared equals a squared minus 2ac plus c squared. Now, we substitute these into the bracket. Step 3. Combine like terms. Grouping all a squared, b squared, and c squared terms. And then the cross terms, we get 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ac. Let's write that inside the bracket. Step 4. Factor out 2 and simplify. Pulling a factor of 2 from the big parentheses cancels the 1/2 in front. That leaves us with parentheses a plus b plus c times parentheses a squared plus b squared plus c squared minus ab minus bc minus ac. Step 5. Recognize the identity. We recall that a cubed plus b cubed plus c cubed minus 3 abc equals parentheses a plus b plus c times parentheses a squared plus b squared plus c squared minus ab minus bc minus ac. So our expression matches that right-hand side exactly. Therefore, the original left-hand side equals a cubed plus b cubed plus c cubed minus 3abc. We have proven the identity. The identity is a cubed plus b cubed plus c cubed minus 3a. We have proven the identity. The identity is a cubed plus b cubed plus c cubed minus 3a. bc equals 1/2 times parentheses a plus b plus c times the sum of squared differences. Well done. In this quick walkthrough, we will simplify a classic symmetric algebraic fraction using a powerful identity. First, let us display the example and the exact expression we will simplify. Now, here is the key identity we will use. 1/2 times the sum, left parenthesis x plus y plus z right parenthesis, multiplied by the bracket of squared differences, equals x cubed plus y cubed plus z cubed minus 3xyz. Because the numerator matches the right-hand side of the identity, we can rewrite it as 1/2 times left parenthesis x plus y plus c right parenthesis times the squared differences bracket. Since the same squared differences bracket appears in both numerator and denominator, they cancel out, leaving 1/2 times left parenthesis x plus y plus c right parenthesis. That is the simplified result. Quick challenge. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.